Okay, let's look at a multi-part problem out of your book. It says to calculate net present value ratio in payback. Top Cap Company is evaluating the purchase of another sewing machine that will be used to manufacture sport caps. The invoice price of the machine is $208,000. In addition, delivery and installation costs will be $10,000. The machine has the capacity to produce 18,000 dozen caps per year. Sales are forecast to increase gradually, and volume productions for each of the 5 years of the machine's life are expected to be, and that's given to us. The caps have a contribution margin of $6 per dozen. That's important because we need to determine what our cash inflows are going to be from the purchase of that new sewing machine. Fixed costs associated with the additional production other than depreciation expense will be negligible, meaning minimal. And salvage value, that makes it easy for us. Salvage value in the investment in working capital should be ignored. Top Cap Company's cost of capital for this capacity expansion has been set to 14%. So the first part it does in part A, it asks us to calculate NPV, our net present value. So let's start by looking at the years that we have here. So we've got, I'm going to come down one, 2010, 2011, 2012, 2013, and 2014. I'm just going to enter in the sales there. 5,400 dozen, 8,400, 12,750, 13,950, and 18,000. So your book doesn't come right out and say what our cash inflows are. Most problems they would be given to us, but they don't here. Instead, they're giving us the volume of sales, and we'll have to multiply that by the contribution margin. So it says the contribution margin per dozen is 6. So I'm going to go ahead and copy that $6 down, and then we'll do the calculation, and that will give us our cash inflows essentially from the purchase of this equipment. So we'll take the 5,400 times the $6 contribution margin. What happened? Try that again. 5,400 multiplied by the $6. And now I can just copy that formula down. If I grab this bottom corner and I get to that little X or cross. So here's my cash inflows for each year now. And then we need to go ahead and calculate the net present value. It says the cost of capital has been set to 14%. I'm going to go ahead and add that up here, 14%. Okay, so at the bottom of this column, I'm going to go ahead and calculate. Not calculating the net present value just yet because I have to subtract out the cost of the machine. So let's go to our formulas, financial, and we'll come down to NPV, or net present value. All right, so it asks for my rate. That's why I like to put it in a separate box. I'll just click on it. It'll automatically reference that cell, and then if I have to make any changes later, I've already got that calculation saved. So value 1 here is going to be 32,400. Value 2, 50,400. Value 3 is for 2012, 76.5. Value 4, 2013, and I have to scroll down a little further to get value 5, 100,000, 108,000. Okay, that looks good. We'll go ahead and hit OK. Okay, let's go finish this up. Then we need to subtract out our initial cost. Okay, so our initial cost was the $208,000 invoice price of the machine. So let's go ahead and subtract the $208,000. However, we also had to pay $10,000 in delivery and installation costs. So that is going to be an additional outlay of money. So we should be subtracting $218,000 to get our actual net present value. So let's go ahead and we'll run that calculation here. Take the 224,486.47 go ahead and subtract then the initial cost of the machine, the sewing machine. You can see I added that, but I had it as a negative. So however you want to do it is fine as long as you get it subtracted. Gives me a net present value of $6,486.47. So this project would be acceptable. Let's see what the next part of our project asks us to do. Calculate the present value ratio of the investment. Okay, so that present value ratio is also known as a profitability index ratio, and essentially what we need to do is take the present value of the future inflows and divide it by our initial cost. So we will take our 224,000 and then we're going to divide that by the initial cash outlay, and that should give us an answer here. That's not right. It's not in dollars, so we need to change it. It's just 1.03. Again, a higher number here would be preferred. So we just want a regular old number. That's fine. Oh, it's a. I don't know why it's coming out as a negative. Sorry about that, since this was, I had that as a negative up here, the 218,000. If I change that, I can change this, and then we won't have that problem. Okay, so we get 103 as our profitability index ratio, which is pretty good. So the next part of the problem asks us to calculate the internal rate of return. So I'm going to slide this over. It's the same basic data, and we can actually use this column that we've already started here. So I'm just going to move it over here. Didn't like that. I'll have to paste it special. Okay. So this is to calculate our IRR. Come back up here. This is part C, and IRR is what we're calculating now. So let me copy these numbers over too so we don't lose track. Okay. The only thing I'm going to add up here is a column for the purchase of the equipment. Let's see, when does it say we purchased the equipment? Okay, the problem actually isn't very specific about when they purchased the machine. If they purchased it in the prior year, in 2009, or if they actually purchased it in 2010. I'm going to go ahead and assume it was purchased in the prior year because it says sales gradually increase. So I'm going to put in that negative 218,000 as an outflow. You could also combine that in 2010 in some cases. So I would just take the 32,400 minus the 218. And again, we'll let Excel do all the hard lifting for us. Go back up to our formulas, go to financial, scroll down to get IRR, and then we just highlight all these values and we hit enter. And it says our internal rate of return is 15%. Can add a few decimal places there. But our cost was 14%. So an internal rate of return higher than our cost, again, is a good sign, and we would continue with that project. All right, and the very last step is to calculate the payback period. So I'm going to slide this over one more time, and we'll go ahead and we'll add another column here for payback period. And I can probably use the same information that we just used for our internal rate of return. What we're looking for is actually, let me delete this out, the point where we get our $218,000 back. So how long does it take us to get that amount back? So we can just take the $218,000 and we can start adding our inflows to see how far we get. So we can run that calculation again, or I can lock that cell by putting a $sign in front of the column, which is G, and a $sign in front of the row, which is 3. And then I can just copy this down. Didn't like something. Let's try it again. Oh, because I'm not taking cumulative. I'm sorry, we need to adjust this. So it needs to say the year prior and then plus our new cash inflows. Okay. So somewhere between 2012 and 2013 we're going to get a payback because we're finally positive. So the way to calculate how far into 2012 we're going to be before we get all of our money back is we'll go ahead and take that 57,700 and divide it by the amount to be recovered in the following year, which is the 87,700. Oops. Okay, and I'm just going to calculate that for us right here. Oh, I hit subtract. I need to hit divide right there. And I may need to get rid of that negative as well, but it's 0.7. So if you take 0.7 times 12, so somewhere around the 8th month. So it's going to take us 1, 2, 3 years and 8 months to get payback on that particular project. Hope that helps clarify things a little bit. Thank you.